So now we know how to expand, say, a plus b whole power n. Correct? You may write it in different forms, x plus y whole power n, etc. But we are interested to know how many terms are there in this expansion. It's not that difficult. You might be able to guess it easily, but still, how many terms do you think are there in a plus b whole power n? So if we calculate, just for example, let us see for a plus b whole square, what do we get? Right? If we get a plus b whole square, we know there are three terms. Okay. A square plus b square plus 2a. Similarly, a plus b whole cube we'll get four terms. Okay. Just because we got 3 and 4 for the uh, whole square and whole cube term, we can just assume that it will be n plus 1. But we already know the expansion, right? And just to get a trend, we are trying to figure out. So what about this NC0, say NC1? There are other terms like a power n, etc. I'm just ignoring the a terms, a and b terms, okay? Just writing NC terms, just because it's counting is easy. So n plus 2, so it will end with NCN. Everybody agrees. So if it ends with NCN, so how many terms? Because then there's no other term. Every term has a binomial coefficient. Okay. So it is NC0, 1, 2, up to n. So there should be n plus 1 terms. Right? This you will be able to figure out. But suppose I say, what about a minus b term? Okay. Or I multiply this with other terms like say a plus b, so on, right? We should be able to calculate at least the number of terms. Whenever the powers are higher, nobody expects you to write down all the terms. Because it will be 10, 12, 20 terms, right? But we should at least be able to figure out how many terms are there. Okay. Look at a couple of problems. We'll try to understand how many terms. Find the number of terms in this expansion. Now, if I ask you only this expansion, x plus a whole power 75, you know that there are 76 terms. Okay, it's easy. Okay. Now you have to figure out in the sum how many terms are there. Now what happens? See, it's x power 75. So let me start x power 75. Okay. Next term is even power, right? So x power 74 into a. Okay. If you want, we'll let us write the NC term or binomial coefficient. So it is 75 C1. Right. So to make it easier, what I'll do, instead of writing 75, I'll simply write C1. Okay. You know n is 75, so we can assume n is 75. Next, it will be plus C2. Whenever I write C2, it means 75 C2. So x power 73 into a square. So on. It ends with a power 75. The other part. Now this is x power 75. Now it's important we have minus sign. So it is minus C1 x power 74 into a. Because of the minus of this, as long as a has an even power, we'll get a plus. So next term will be plus. So it is C2 x power 73 a square. Because this minus a whole square will be a square. Okay. Next should be minus 1. So we get an idea. Okay. Now, how many terms are there? The total 76 terms here. Okay. So you can guess half of the term will have positive sign, half of the term will have negative sign. So total number of terms. So these terms will get cancelled. All the negative sign term in the second expression will get cancelled with this. So how many terms remain? Half of this, which is nothing but 38. So totally you will have 38 terms. Find the number of terms of the following expansion. Now we don't have any particular binomial standard form, right? We don't have a plus b whole power n, etc. But still, we just have multiplication. So a plus b whole power n is nothing but multiplication itself, a plus b n times. Okay. But the advantage there is we are going to get similar terms which we add. Okay. Now we are not going to get that. So how to figure out how many terms are there? Can we start with a smaller example? just multiplying two terms and figuring out. So what I'm going to do is a1 plus b1 into a2 plus b2. Right? If I multiply this, I'll get, say, a1 I have to multiply to both the terms, correct? Then I have to multiply b1 to both the terms. So each will correspond to two terms. So what are you going to get finally? a1 a2 plus a1 b2 plus b1 a2 plus b1 b2. But in other words, one of the term here is going to get multiplied here, right? And give me two terms. The second is going to multiply here and give me two terms. So totally four terms. Suppose I multiply this four term to the next a3 plus b2. Okay. Just by logic, nothing else. Can you see that a3 is going to get multiplied with these, okay, and give me four terms, right? So a3 is going to give me four terms, and b3 is going to give me four terms. Total eight terms. Can you see where we are going? Now, if I these eight terms, if I multiply again for next term a4 and b4, right? So eight terms from this, eight terms from this. So every time we're getting the number of terms multiplied by two, right? Or doubles, correct? So first I had two terms. When I multiply with this again, 2 into 2, four terms I got. Again with this 2. So how many 2 should I multiply? That's the question. So this is 2 power 1, this is 2 square. So at the end we're going to get 2 power n terms. We are supposed to get 2 power n terms itself. Okay. But whenever I do a plus b, I'm multiplying similar terms, right? So that time what happens? AB is same as BA. So that's why the number of terms reduces. Okay. So you remember in this, if I do whole power n, I'm going to get only n plus 1 terms. But here actually, if all the terms are different, I'm going to get 2 power n terms. Number of terms in this expansion. We are not expected to multiply both and try to figure out. Okay. So the whole trick lies if you know what is 1 minus x into 1 plus x plus x squared. I hope you have seen this form somewhere. Nothing but 1 minus x cubed. That's it. Because if you divide, if you remember, you're going to get this as a quotient. If you're not sure, what we'll do is we'll simply multiply and see. Okay, let me multiply. So 1 I have to multiply with all the terms, x plus x squared, minus x with all the terms, 1 plus x squared. Fine. So what I'm going to get? 1 plus x squared minus x squared minus x squared. You can see these terms get cancelled. All that remains is 1 minus x. Okay, one more issue is the powers are not exactly same. But I can get rid of that. I can write 1 minus x into 1 minus x whole power 50 into 1 plus x square whole power 50. Now I can certainly multiply those two. So it is 1 minus x into 1 minus x cube whole power 50. Now, how many terms are there in this expansion? See, the whole point is we know how to calculate this very easily because now it is in the standard form. So this will be 50 plus 1 terms only. Okay. If you are directly calculated, you might write the number of terms, but you can see there might be like terms. Okay. The whole idea is you have after expansion, you have to combine the like terms, right? Here combining is really difficult, tedious. Okay. But here now you can certainly say this has 50 plus 1 unique terms itself. That 51 terms. Okay. Now I am multiplying with 1 minus x. Now the whole trick lies. Now let us look at the terms, what I am going to get. Okay. Just instead of randomly saying, I'm going to get 51 into 2 terms instead of randomly guessing. Let's figure out what are the terms you're getting. So let's look at the expansion. It is 1. Next is, because it's odd, right? So minus nc1 or 50c1 into x cubed. Okay. Next should be plus nc2 into x power 6. Next should be minus nc3 into x power 9. So on, it will continue. At the end, what I'm going to get is, because it's even power, x power 3, that is x power 150 with a plus sign. Right? Look at the terms here. 1 I'll multiply to all the terms. I'll get 50 terms. Right? Again, x will multiply. Sorry, there are 51 terms, right? Not 50 terms. So if I multiply, I'm going to get 51 terms. Right? X will multiply to each, again I get 51 terms. Now the idea is whether there are some common terms which will combine. That's the whole goal. Right? But you can see that each of the terms differ by x cube. Okay. So just to give you an idea, so when I multiply with 1, I'm going to get these same terms. But when I multiply with x, I'm going to get minus x. Next term would be c1, it will be plus x power 4. Next will be x power 7, x power 10. Can you see none of the terms would match? So I'm going to get all different terms. So I'm going to get 51 terms just by multiplying with 1 and 51 terms by multiplying with x. So total 1 or 2 terms. Now, if there were no 1 by 5th power and 1 by 10th power here, the problem. So we would directly say there are total 56 terms, 55 plus 1, because all of the term would be free of radical. Now, it's asked which of the terms will be free of radical. Now, randomly, let's try to figure out by simply writing down the expansion. There's a better way if you know to write the general term, but we have not learned that, right? So let's directly try. Right? What are the terms, etc. Now, first term would be, say, y power 1 by 5 whole power 55. Right. Next term, because everything is plus, so C1, I'll write C1. C1 means 50 by C1. Okay. Into y power 1 by 5 whole power 54 into x power 1 by 10. Can you see that this first term what I wrote down? So 55 by 5 will be 11. So it will be free of the radical in the power. Free radical signs. So we don't need radical signs in the power. Right? So this is one of the terms, just to figure out what are the terms. Next term, if you see C1, y power 54 by 5, and here it's 1 by 10. Both of the terms, okay, both of the terms have radical. Okay. Radical power, just its fifth root, and which can't be simplified. Okay. Therefore, this won't be my term. So I have to try to figure out how many such terms are there. So you can guess, right? When will be next time? When the power and the radical sign should divide. Okay. So when it will happen? This is 55. 54 won't happen. 53, 52 won't happen. Next, you can think of, okay, is 50, say 50. So 50 by 5 will happen. X power. This also should be 50. Sorry. So this is 50. This is reducing, right? So this reduced by 5. So the x part should increase by 5. So x should be 5, right? Now you are right in saying that y power is y power 10. That means this is free of radical. But if you look at the x power, it's still half. Still half. So this term also won't work. We need free of radical. Obviously, we need both the variables to be free. So you can guess now. Obviously, I have to go to 45 so that it's divisible by 5. When it's 45, what will happen? X will be 10 by 10. Because see, this power will remain 55. Okay. So when you reduce this, you can see when you reduce by 1, this will increase by 1. So this you have reduced by 10, this increases by 10. Now can you see what is this? This is y power 9. This is x power 1. Can you get a pattern now? This is y power 11. You can guess what will be the next term. If I take 40, it will fail because x power won't have a proper whole number. So if I take next number should be y power 35 and x power 20. Right? Now you can see both are whole numbers. So it will be y power 7 x square. Okay. Next again you can guess y power 5, I guess, right? So y power 6 won't work because of x. So this will be x cube. You don't need to write down the terms. You're trying to count, right? That's why I'm just writing down so that it's clear. It's y cube into x power 4. Then say, I'm ignoring these coefficients, okay? Because they have not asked us what is the coefficient. Okay. We know that all these binomial coefficients are whole numbers. Okay. So we need not worry about what value it takes. Okay. So those values will always be whole numbers. So What about next? It's y power 1 into x power 5. I can't increase it because I'll go to negative values. So these are the terms 1, 2, 3, 4, 5, 6. The 6 terms which are free of the radical. Here. Okay. Find the value of one of the, whenever we have such huge numbers, okay, there will always be some kind of trick there involved. Now we can't randomly sit and multiply. I know we'll get an answer, but just think in a competitive exam, if you sit and simply multiply, then half of the time will be wasted on this particular problem itself. So if you had observed the pattern, I think you can guess what is the power. Numerator is nothing but 18 plus 7 whole cube, right? I think that's the first thing you could guess. A cube plus B cube formula. Similarly, below, if we see the same, it is 3 plus, this is nothing but 2 power 8, so 2 whole power 6. If you're not sure, let's see, this is 3 power 6, correct? Next term should be 6c1 into 3 power 5 into 2. Let us see, 6c1 is there, 3 power 5 is 243 into 2. Similarly, 6c2 is what? 6 into 5 divided by 2. Correct. So that is 15. So this is 6c2, 3 power 4 into 2 square. Can you see the pattern? Okay. At the end, sorry, this is 2 power 6, right? 2 power 6 is 64. So what do we get? It's 25 whole cube divided by 5 power 6, which can be written as 5 power 6 divided by 5 power 6. Because 25 is nothing but 5 square. So this is nothing but equal to. So a lot of calculations. At the end, what you are going to get is nothing but 1. Find the in the expansion. Okay. So we are trying to figure out what is the fifth term. Okay. Now again, you can define terms in a different way. Okay. Let us assume we are starting with 1. Okay. Next term would be 8c1 into 1 power, which is 1 itself, into minus 2x. Next would be 8c2 into minus 2x whole square. 8c3. So they were asked even the coefficient of x cube. So both will try to figure out in one go. Minus 2 whole power 3. Next is 8c4 minus 2 whole power 5. 8c5 minus 2x whole power 6. Now look at it. Sorry, we have missed 4. So this is power 4, this is power 5. I'll write it down. So this would be power 4, this would be power 4. So this would be your first term. Second term, third term, fourth term. This is your fifth term. Now you may say these are different things. See, x power 5 is actually here, but the fifth term is here because remember we don't have n terms, we have n plus 1 terms. We look at the general formula, you'll understand how to get it. But this should be very clear. So this is the fifth term. Okay. So what is this equal to? 8c4 we have to calculate first. But I think we can leave it as it is. If you want, you can figure out the value. So fifth term is nothing but 8c4 minus 2 power 4 x power 4. Or it is 8c4 into 2 power 4. 2 power 4 is nothing but 4 into 4, 16. 16 x. If you want, you can figure out what is the 8c4, not an issue. But just to write the fifth term, we need not do that. The coefficient of x cube. Now we probably need the number. So let's try to figure. So this is a term which has x cube. Okay, no other term will have x cube. So let's see. Coefficient of x cube is nothing but 8c3 into minus 2 whole cube. Correct. You have to write only the numbers. X we can ignore. So minus 8 into minus 8 is coming from this. 8c3. What is 8c3? 8 into 7 into 6 by 3 into 2 into. Right. So 3 into 2 into 1 is nothing but 6. 8 into 7. Right. So it is 56. 56 into 8 again. So 8 6 are 48. 8 5 is 40, 44. So minus 448. This would be the coefficient of x cube. Again, a binomial expansion is given. We are supposed to find the value of P, Q, and R. So we know the expansion. So one equation is already given. So what we do? We'll write our own expansion, right? We try to equate the two equations because both the equations should be same, right? So it's P minus x by 2 whole power 6. Half x is nothing but x by 2. So this is P power 6. Next term would be 6c1. Then it's two terms, so it's P power 5 into minus x by 2. Agree? That is minus x by 2. I am just curious. See, look at the term. It should contain exactly one x. Right? Next term, because we have r also. Next term would be P power 4 now, and this would be minus x by 2 whole square. The coefficient is 6c2. Other terms we need not write because we don't have any information about them. Okay. Now, what do we know? Let us just equate these two equations. So I know that Q should be equal to P power 6 because this term should be equal to this term. Next, I know that minus 76 should be equal to, there's a minus sign here also, so minus 6c1 P power 5 into half. Why? That is the coefficient of x here. What is the coefficient of x? If I write x separately, minus 6c1 P power 5 by 2. Correct. That's all. The coefficient of x are equal. So what is it? First, we don't have a value of q, we don't have a value of p. Okay. We have to try to figure out. So let us look at what are the factors here. So one is minus sign and minus sign will get cancelled. And 6c1 is 6. So 96 by 6 into 2 should be equal to p power 5. What is 96 by 6? The ones are 36. 6 are 16 into 2 is 32. So we directly got what is P. P is nothing but 2 because 2 power 5 is 32. Once you get P, you got Q also, isn't it? So Q is nothing but 2 power 6, which is 64. So we got P, we got Q. All that remains is R. So R is nothing but the coefficient of this term. So let us write down R is equal to coefficient of that term is 6c2 P power 4 into minus half whole square. Rest is x square term. So we are equating x square and x square term. Okay. So R is 6c2. 6 into 5 divided by 2. P we already know is 2 power 4. Okay. So this is half square. So you can directly cancel this half square and this 1, 2. So this will be total 3 2's have cancelled. So 4 minus 3 is 2 power 1. Okay. Remaining is 30. 30 into 2 is 6. So R is nothing but 60. Now, because we know the binomial expansion, right? What we're trying to figure out is a particular term. Okay. So, for example, if I have a plus b whole power n, okay, there are n plus 1 term. Suppose I ask you a 10th term. Can you directly write down what the 10th term? Obviously, now if you write in two different orders, like when somebody is writing from this side, starting from b power n, somebody starting from a power n, we'll get different terms. So we'll assume that everybody starts from the first term itself. That is a power n plus nc1 into a power n minus 1 into b. Okay. So everybody goes in the same line. Then when I'm talking about second term, it is this term. Even you are talking about second term, it should be the same term. Right? So plus nc2 a power n minus 2 into b square plus nc3 a power n minus 3 into b cube, so on. At the end, it will end with b power n. Okay. If you want, you can write nc0 here and ncn. Just that's used to, because they are one, we usually ignore. Okay. The question is, are you able to figure out this is a fourth term? Can you directly write what is the fourth term? Or if I ask you the rth term, tr, okay, are you able to figure out? That is the whole thing. So just let us observe. Let us observe. Okay, what do we have? Let me write down. This is the first term. First term will denoted by t. This is the second term. This is the third term. This is the fourth term. This is n plus 1th term. Okay. Because there are n plus 1 term, so that should be n plus 1. And you see that if this is r, okay, this is not related to r directly. All are one less. Okay. So this is third term, this is 2, this is 2, this is n minus 2. Okay. So therefore, even while finding terms, what we do is we simply find t plus t r plus 1th term instead of playing r plus 1. We'll figure out why. Look at this. This will be NCR. Okay. Looking at the pattern, this is 4, this will be 1 less. This is 1 more, 1 less. Okay. Next will be a power n minus r. Again, 1 less. B power r. Can you see that? Okay. Now you may say, I can take TR as NCR minus 1. Say, similarly, there n minus r minus 1, b power r minus 1, right? You can do that, okay? But the problem is we are using one of the standard formats, right? So if everybody sticks to that, it will be easier to understand. So we do this. So these terms are easier. Even though you're taking r plus 1 here, these terms are much easier, okay? The second thing is we fix r, right? So we start r from 0. We start from 0, I'll get the t1 term. R equal to n, I'll get this term. Okay. So that will make it clear where r lies. So it's from 0 to n, totally n plus 1. Now suppose I ask you t10. T10 is nothing but t of 9 plus 1. That means, that is, we don't know what n is, so I'll keep n as it is. Okay. NC9, a power n minus 9, b power 9. That's it. So you can see before also for the radical sign, etc. This will be really helpful. You can directly figure out how. So if I go back to the problem, okay, of the radical sign, whichever the term is here. Look at this. Shall I write the general term of this? Okay. X power 1 by 10 whole power 55. What will be the general term? Can you figure out? So it will be NCR. Okay, obviously it is t of r plus 1 the term. NCR into y power n minus n is 55. Okay, 55 minus r by 5. Sorry, this 5 is divided by whole term. Right? So 55 minus r. This is 1 by 5. So it is 1 by 5. Next is x power 1 by 10 remains as it is. Whole power r. So it is x r by 10. Can you see what we got? So I want it to be radical, right? Look at this. R by 10 should be some integer or a whole number, isn't it? That's only the case. So R should be a multiple of 10. So it can be 10, 20, 30, 40, or 50. There are only 5 cases here. Okay. But because R is, as I said, starts from 0, we should include 0 also. Because x power 0 is also 1. Got it? Now, obviously, we can't stop at x. We have to check for y. Look at all these numbers. Okay. At when r is 0, these are r equal to 0, 10. So when r is 0, this will be 55 by 5. Divisible, not an issue. R equal to 10 minus 10 by 55. Still divisible. Any of these numbers I take, 30, 40, 50, all are divisible. Okay. So without even writing the terms down, by using the general term, we are able to figure out much easier. So this is one other approach which we have. Always calculate. There's no harm in calculating like this. But once you write the general term, the calculation becomes much easier. Find the indicated term in each of the following expansions. So we have to try in this expansion the term which is independent of x or the coefficient of x power 0. Either way you can term it, right? Okay. Now look at it. It makes sense, correct? When we multiply this and something divided by x, there might be terms which is independent of x. Let us write the general term. Okay. One method is write all the terms. Very tedious job, right? So let us write the general t of r plus. What is it? So it's NCR into 2x whole power r into minus sign. If you want, you can ignore it, but let us write it down. Because if we are supposed to write the coefficient, we need to know what it is. X square whole power r. This is not r. This should be n minus r. So we know n. So let us write it is 12cr. So it is 2x whole power 12 minus r into minus 1 whole power x square. Now what should I do? I want x power 0 term. Okay. So can I combine all the x terms just to see what I'm getting? Okay. So to combine all the x terms, this one I'll write it as minus 1 whole power r divided by x power 2r. Okay. Remaining here, again I'll split it. Okay. So this will be 2 power 12 minus r. 2 power doesn't matter. Remaining x power 12 minus r. Fine. Because of the product, I just split it. A b whole power m into a power m into b power m. Okay. Next, this is into minus 1 whole power r into x power 2r in the denominator can be written as x power minus 2. Now can we see just by combining terms? This is minus 1 whole power r into 2 power 12 minus r into 12cr x power term. So x power 12 minus 3r. This is the product of this and this. Why did I do that? Now I know that the power should be equal to 0. When is the power 0? When r is equal to 4. Can you see that the fifth term, because it's 4 plus 1, fifth term will be independent of x. Now if they ask you to find a coefficient, simply put r equal to 0 here. So it's r equal to 4 here. So minus 1 power 4. 2 power 12 minus 4, which is 8 into 12c4, and you can see that this is the exponent. So this will be the coefficient of the term which is independent of x. The term, same problem, okay, generic form. Okay. The power is different. We have to figure out when we get 1 by x power 15. So let us write the general term again. E of r plus 1 is nothing but say NCR 2x whole power n minus r into minus 1 by x square whole power r. Substituting again n equal to 12, so it's 12 cr. So 2 power 12 cr is directly separated 12 minus r into x power 12 minus r into minus 1 whole power r into x power minus 4. We already done this, so it's easier now. What do we get? 2 power 12 minus r, and all the constant terms will just keep one side of it. So minus 1 power r into 2 power 12 minus r into 12 cr into x power 12 minus 3r. So 12 minus 3r should be equal to, this is the denominator, so this is nothing but x power minus 15 should be minus 15. So what is r? So r 3r is nothing but 18, 28. So r is nothing but 7. Right. So if r is 7, you can just figure out what term it is. That's minus 1 power 7 into 2 power 12 minus 7 into 12 c7. This will be the coefficient of x power minus 1. Okay. So any power, always write the general term. Okay. But remember, writing the term, usually students make this mistake. They just write it as 7th term. But r is 7. The term is actually 8th. Find the indicated term. So suppose this expansion is given, you are trying to figure out the middle term. Any expansion, okay, what would be the middle term? Can you think about it? A plus b whole power n. What would be the middle term? Okay, let us look at this specific case because there are power is 10. That means there are 11 terms, right? Let me write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because it's an easy exercise, you can write it down. So NC0 will start here, right? This will be NC1. Let me write N also because we know what's N. 10C0, 10C1, 10C2, so on. Last will be 10C2. And you see that this term, sixth term, should be a middle term. Correct? You know how to write the sixth term. Okay. So what is T6? T6 is T5 plus 1. That is NCR, which is 10C5 into 2 power 10 minus 5 into x square by 2 whole power 5. That's it. So it is 10C5 into 2 power 5 into x power 10 divided by 2 power 5. So these two will get cancelled. So all that you have is 10C5 into x power 10. That will be a middle term. Now we're trying to figure out what is the middle term in any general expansion. Just remember, the middle term is different from the greatest term. Okay. Just because we are talking about a middle term need not be greatest. Okay. It might be greatest in most cases, but it is not always greatest. So what we are trying to figure out is just what is the middle term. Okay. Now, just for example, if something is power 10, we are just seeing right? A plus b whole power 10. Okay. So you got the sixth term as your middle term, right? But that you got just because look at this number 10. Okay. We had what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So because this is middle term, because there are 5 terms, this said 5 terms, that's it. That means when I have odd number of terms, there's no problem. That this is a middle term. Right? What if you have even number of terms? Or for example, if I take a plus b whole power 7, okay, whole power 7 means 8 terms. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, only 8 terms. So we stop here. Look at this. 3 is this side, 3 is this side. Middle term, there's no any specific middle term. But so we usually what we do is we say that both these two terms, that is fourth term and the fifth term, are the middle terms. What? See, look in terms of your binomial coefficient. If you think about it, look at this. Okay. Not the terms a and b, only the binomial coefficient. Look at what happened. So look at this term. This is 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, 7C7. Look at these two terms. Aren't they equal? Isn't 7C3 equal to 7C4? Okay. This is equal. Okay. And rest of the terms are actually lesser than these. Okay. So they are the middle term. Okay. And it makes sense right now. If both the terms have the same coefficient, okay, therefore they both are the middle terms. So what happens if it is an even number here and an odd number of terms? Look at it. It will start with say 10C0, 10C1, 10C2, 10C3, 10C4, 10C5, 10C6. And look at this. These two terms are same. Okay. But this is a unique term, and between you'll have only one term. So if you are to talk in terms of power, if the power is even, okay, suppose I say a plus b whole power n. If n is even, okay, then the middlemost term will have a single term. Fine. You can directly say the binomial coefficient at least is nc n by 2. Clear? So in this case it is 10c5. 10c 10 by 2. Suppose your power is odd. So let me write here a plus b whole power n. N is odd. Now we know that there are two middle terms, so it should be nc. Because it is odd, so I'll do n minus 1 by 2 and n plus 1 by 2. It will divide by 2 only if it's even. So n minus 1 is also odd, n plus 1 is also, sorry, n minus 1 is also even, n plus 1 is also even. In this case, you can see that 7c, 7 minus 1 by 2, and 7c, 7 plus 1 by 2. These are the two middle terms. You're more interested in the greatest term than the middle term, but you should at least understand, okay, which is the middle term. Okay. If in a question is asked, figure what is the position of a middle term, directly you should be able to figure out. So in this expansion, we have to, where AB is not 0, the coefficient of x power 8 is 0 is given. So that information is here. You have to find the ratio of a by b, the simplest one. So what do we know? We know this is 1 plus x. And we know this is a minus bx whole power 12. Okay. So I can write the general term of this expression. Figure out. Can I write that? Let me write only this part. Because the entire part generally because I can't write it right now. Because binomial expansion into something is given. Okay. So for this, TR is nothing but NCR into a power n minus r into minus bx whole power r. N is 12, so it will be 12cr a power 12 minus r minus b power r into x power r. Let me write it separately. Now, what did they say? They told you that x power 8 quotient is 0. How is this possible? That is the first one. Because look at it. Shall I write x power 8? To get it, so this is x plus 1, sorry. To get x power 8 here, right? What should I do? This should be t9. So let me write this as t of r plus 1 itself. It's not changed there. So let me write t9 separate. T9 separate. So 12c9 into a power, sorry, 12c8, right? This is 8 plus 1. 12c8 into a power 12 minus 8, which is 4, into minus b whole power 8 into x power 8. Now, can you see this x power 8? This cannot be equal to 0 because only this is not 0. A cannot be 0 because it's given that AB is not 0. AB is not equal to 0 means neither A is 0 nor B is 0. Even this is not 0. Then how is this coefficient equal to 0? Now, what term you have missed, you have to get it into the picture, which is 1 plus x. Now, look at it. If there is some term here, x power 8, okay, this into 1 will give you the same term x power 8. But there's another term here, x power 7. When x multiplies with this, will also give you x power 8. So you'll have actually two terms, right? Which is giving you the power x power 8. You have to add them. That sum is equal to 3. Clear? So now what should we figure out? We already did this. So let's try to figure out what is T8. Because I need the x power 7 term. So it is 12c7, right? A power 12 minus 7 minus b power 7. This is x power 7. Look at it. 1 plus x can give me x power 8 only in two ways. One is x power 8 coefficient. One is x power 7 coefficient. No other thing. There are only two ways in which I can get. Okay. So this will give me x power 8 and this will give me x power 8. So let me add those two. The coefficients here and the coefficients here. That I know is equal to 0. So it is 12c8 a power 4 b power 8. Here is a minus sign, so I'll add them. 12c7 a power 5 b power 7 is equal to 0. Okay, it's just the sum of the coefficients. This minus sign, so they both should be equal. Okay, so 12c8 into a power 4 b power 8 is equal to 12c7 into a power 5 b power 7. This is what the condition. Can you see a power 4 is common, so this will get cancelled. B power 7 is common. Both are not equal to 0, so I need not worry, I can directly cancel them. What remains? Exactly the terms what we want, a by b. A by b, by taking b the other side, is equal to 12c8 divided by 12c7. Let's simplify it, figure out. 12c8 is what? 12 into 11 into 10 into 9 divided by, right? 12c8 is nothing but 12c4, so easily write 12 into 3 into. If you want, you can use a formula if you're not comfortable. What is the formula? NCR is equal to n factorial by r factorial into n minus r factorial, right? So that means 12c8 is nothing but 12 factorial divided by 8 factorial into 8 minus 12 minus 8, which is 4 factorial. That way I got this. Okay. Now 4 into 3 is 12, so this will be cancelled. Or let me keep it as it is instead of cancelling. Why, I'll tell you. Look at the denominator. Denominator is 12 into 11 into 10 into 9 into 8, 5 terms, right? 12C7 is 12C5 divided by 5 into 4 into 3 into 2 into 1. Now instead of cancelling, I can cancel this entire thing here. Easy to cancel. 4, 3, 2, I can cancel this entire. What it means? 1 by 8 by 5. Okay. Or is equal to 5 by 8. So A by B is nothing but 5 by. So all from the information given. Now instead of having one term with the coefficient with the power x power 8, we had two terms. So the sum should be equal to 0. The first four terms in this expansion, okay, in ascending powers of x is given. To find the value of a, b, c. Again, binomial expansion. Only problem is we don't have two terms. We have more than two terms. So writing in this won't be so direct. Maybe you can guess 81 very easily, but rest of the terms may not be so easy. But the power is less. Let us write down a plus bx. Let's combine these two as one term. Okay. Plus cx squared. Right. Let us try to write the expansion. What it is. So 4c0 into a plus bx whole power 4. Next term would be 4c1 into a plus bx whole cube into cx squared. Right. Next term would be 4c2 a plus bx whole cube into cx square whole square. This is a whole square, sorry, not whole cube. Can you see that from here we can stop writing the terms? Why? We are interested in x power 0, x power 1, x square, x cube. What is this term? This term is x power 4 into some constant. That power will never reduce because we don't have anything in the denominator. Okay. Power only can increase. All the terms here have x power 4 or higher terms. So next term would be x power 6 and higher. Similarly, it will increase. Okay. So from here, you can skip the terms. So obviously, even though it's very lengthy, you don't really need to write all the terms. You have to be smart about it. Look at the terms. First term, 4c0 into, now this expansion we know, so it's a power 4. 4c0 is 1, so let me just ignore it. Okay. So a power 4 plus, now it is 4c1 into a cube into x plus 4c2 a square into x square plus 4c3 a into x cube plus x power 4. Right? Again, we could have ignored a couple of terms, but let us write down because it's not many terms. 4c1 is 4 into a plus bx whole cube, a cube plus 3 into, instead of writing 3c1, I directly do 3 into a square into bx. Next would be again 3 because 3c1 is same as 3c2. So 3 into a into bx whole square plus bx whole cube. I need not again write all the terms. Look at how the terms outside. It is cx square, right? It is cx square, sorry. So it will be cx square, yeah, as it is. And this is x square, we need maximum x cube. So can I ignore these terms? I can, because the product will have higher powers. Similarly, can I ignore this x power 4? Yes, I can. Higher powers. Let us try to match them now. Let me write what are the terms independent of what terms we're getting. So for example, this is constant. Here, this is not constant. This is multiplied with x square. So there is no constant. So only one constant I have. So let me write in a different color. So constant is a power 4. So a power 4, if I equate to 81, I'll get a is equal to 3. Very easy. Okay. Next term, coefficient of x. There's one x term here. Look at the terms here. None of the terms have x coefficient. Minimum is x square. So the next term would be 4c1, which is 4a cube into x. Is it matching with our number? Just to check. We got a is equal to 3. 3 cube is 80. Sorry, 3 cube is 27. 27 into 4. Right? 27 into 4. Oh, we did a mistake. Okay, while calculating, what we did is, look at this, look at this. There was a b term, there's a b term. You just ignored b term. Okay. Let me just add it quickly. Okay. Nothing will change. The same expression will have b, b square, b cube, and b power 4. This is anyhow ignored because it was bx term. Okay, I just wrote x term. This is bx total. Okay. That's why we are not able to match it. Look at the term. It is actually 4a cube b is equal to 216. Yeah. Not only 4a cube. If it was 4a cube, our answers were not matched. Now, look at it. 4, if I divide, it is what? 5 times 16, 4 times. A cube is nothing but 3 power 3, which is 27. So B is nothing but 54 by 27, which is equal to. So we got A is 3. Let me write down here 3. B is 2. Let's go to C. Now I've taken care of this term and this term. Okay. Now base coefficient of x square. 1x square is here. 1x square I'll get from here. Fine. So let me write down the terms first. 4c2 a square b square x square. This term is considered. Next is 4 into this a cube into cx square. So a cube into cx square. Combining the terms, x square is common. 4c2, what is it? 4 into 3 by 2? 6. So 6a square b square plus 4a cube c. What is this equal to? This is equal to 108, you already know. Let's equate. 6a square means 9. B square, b is 2, 4 plus 4a cube is 27 into c is equal to 108. Fine. So how much is this? 6 into 4, right? It's 24. 24 nines are. Okay, let me write 24 into 9. So 9 fours are what? 36. So 9 twos are 18. 2 16. So 108. So 27 into 4. Let me multiply that only and write. So 27 into 4 is nothing but 108. Right. C is equal to 108 minus 260. If you want, you can actually divide by 108 here only. It will be much easier. Okay. So 108 ones are 108 twos are. So it is nothing but minus 1. Or you can subtract and write it down. Anyway, you like. So C also we got is minus 1. Only one term remaining now is D. You can guess that. So I'll add it. Let me change the color again so that it's not plus this term and this term is contributing to x cube. So it is 4c3 a cube, sorry, a into b cube x cube. This term is plus 4 into 3a square b into c. Right? Again, 4c3 is nothing but 4. So let me just simplify. 4ab cube plus 3 into 4 is 12 a square bc. This is equal to d. But this is the coefficient of x cube. Dx cube should be equal to this. Now all we have to do is multiply 4 into A is 3, B cube is 2 cube, 12 into A square is 3 square, B is 2, C is minus 1. How much is this? 4 into 8, 32. 32 into 3, 96. This has a minus sign, so minus. 12 into 9, so 108. So 108 into 2, so it is 260. Just subtract this, we are going to get B, which is say 116 and 4, 120. Okay. So we got all the 4 values. So 120. Okay. So we got A is 3, then 2, then minus 1, then 120. Can you see by one expansion, just by equating the term, there are a lot of terms. Just by equating terms, we could get so much of information. So be careful, there is always a chance to miss a couple of terms, like just we did for B, right? So try to write it down more neatly and get your answer. Now the coefficients of this and this terms in this terms are equal. Okay. What do you mean by coefficient of the terms? Look at it. In the term T 2r plus 4, okay, and T r minus. Okay. So I'm not comparing the x power, the coefficient, because the x powers are totally anyways 2x power, say, this would be x power 2r plus 3 maybe. Right? This is x power r minus 3 maybe, because it should be 1 less than the term, right? But if you simply equate this, it will be wrong because they're not equating x powers. They're just saying the coefficients are equal. So let me write down what are the coefficients here. So coefficient of this is what? This is nothing but 2tr plus 3 plus 1. Similarly, this is r minus 3 plus 1. Okay. nc 2r plus 3. Okay. Into 1 power something, into x power something, which is x power we can ignore. Okay. And 1 power is anyway 1. Similarly, it's ncr minus 3 to 1 power something into x power. We are ignoring x power because we are interested in the coefficient of that. Okay. The coefficient of that will be the remaining terms. That's it. Now, when are NC terms equal, that means 2 NC terms are given. Okay. How do you equate that? So we know that NCR is nothing but equal to NC n minus R. These are the only 2 cases when they are equal. For example, 5C1 is same as 5C4. How do we know that? Because look at NCR, what is it? N factorial by R factorial into n minus R factorial. Correct. Now, if I have NC n minus R, what will happen? This will remain n factorial. The first term will be n minus R factorial. Okay. But this will be n minus R, which is nothing but R factorial itself. So can you see that we are going to get the same terms? This thing, the product is different, A into B and B into A. That's it. So what does this mean? Sum of these 2 numbers should be equal to n. Correct. That means 2r plus 3 plus r minus 3 should be equal to n. What is the n in this case? N is 18. So it should be equal to 18. So that means 3r should be 18. R should be equal to 6. So what do we need? We need r. So we got it, which is 6. The middle term of the expansion is 1120. Then x belongs to r is equal to. Okay. So middle term is given. Okay. So all our coefficients. So we have to figure out the value of x. Now let us see what should be the middle. This is an even number, correct? So the number of terms is odd. So we know that 5th term would be the middle term. Okay. So what is the 5th term? 5th term is nothing but NC R, and this case it will be NC4. Let me write n also. So 8C4 into x by 2 whole power 8 minus 4 is 4. into 2 power 4. Okay. This gives me 8c4 x power 4 by 2 power 4 into 2 power 4. So these two will get cancelled. We know that this term is equal to 1120. Then we try to figure out what is that. Now they have given x as real numbers just so that we don't consider complex roots. Okay. So 8c4. 8c4 is 8 into 7 into 6 into 5 divided by 4 into 3 into 2. So let me just cancel 8. 3 again I can cancel. This is 2, sir. So 7 into 5 is 35. 35 into 2 is 70. So x power 4 is equal to 1120 divided by 70. So what is this? 7 ones are 42. So 7 6. X power 4 is equal to 16. You can say that x can be either 2 or minus 2. Real values we are considering. Okay. There are only two values, which is 2 or minus 2. It's not given as a positive number, etc. So we can take two solutions. Middle term of expansion 1 minus 3x plus 3x square minus x cube whole power 2n. Now, if you simply directly try to figure out with 4 terms, it's going to be very tedious. All you have to do is see what are the terms inside. If you have figured that out, that inside is 1 minus x whole cube, correct? It's nothing but that expansion, and the problem becomes very simple. This is whole power 2n. I can write this as 1 minus x whole power 6n. Now, even terms for sure, because n will be a natural number. So 6n plus 1 terms, middle term we want. Okay. What is it? 6n c 3n. Now there is a sign here. Okay. If you want, you can write it as minus 1 whole power 3n. Depending on the sign, the middle term is different. If you want, write the general term if you're confused. It is 6n c3n. Okay. 1 power 3n into minus x whole power 3. You're not interested in x, okay? The middle term, but just the sign. So it will be minus 1 power 3n, 6n c3n into x power 3. If the coefficient is asked, directly you can write this. If the term is asked, we'll simply write with term with x power 3.